Welcome back to school, Chapter 1. Let's begin. This chapter is about factors, multiples, primes, and composites. We're starting with Chapter 1, Section 1. There is a list of vocabulary words you do need to know. There are 12. You do not need to copy these down. I have a copy of this in a handout. Please make sure you get a copy of the vocab. Starting on page 4, make sure you have your book open to page 4. Kenya has a collection of 18 rings and she wants to store them in a box. She uses an array. It groups her collection into 2 rows, with each row having 9 rings. An array is a rectangular arrangement, equal number of objects in each row, an equal number of objects in each column. So in other words, this is a 2 by 9. Number 1, write this down as we go. Use tiles to represent Kenya's 18 rings. Arrange the tiles to create other arrays. Describe the arrays you've created. I'm just going to use X's instead of drawing these fancy rings. So the first one I'm going to do is a 1 by 18. So I'm just going to do 18 X's. 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So this is a 1 by 18 array. Put a box around this one. If I get going too fast in the video, just pause it and get yourself caught up. Another array you could do would be a 2 by 9. That one's already done. The final one would be a 3 by 6. I'm going to go 6 across, easier to fit, with 3 rows. So here is my 3 by 6. So there are 3 different arrays you can do for 18. A 1 by 18, a 2 by 9, and a 3 by 6. Question B asks, what mathematical operations did you think about as you create your arrays? Obviously, we thought about multiplication. And you could also think about the inverse, which would be division. C, is there more than one way to make an array with 2 rings in a row or column? Is there more than one way to make an array with 3 rings in a row or column? What that's saying is you can have a 2 by 9 or 9 by 2. A 3 would be 3 by 6 or 6 by 3. D asks, how do you know when you have determined all the arrays for a number? When you've gone through all the factors. Listed all of the factors. How's your cursive reading? Hope it's good. Next page, Kenya notices that the number of rings she used in her row and column are the same as the factor pairs of 18. A factor pair is 2 numbers that have other than 0 that are multiplied together to produce another number. Each number in a factor pair is called a factor. List all the factor pairs that we did. We did 1 and 18, semicolon. We did 2 and 9, semicolon. 3, comma, 6. You do not have to rewrite it. You're not wrong if you do. Order does not matter. That is called the commutative property. How are the arrays you created in question 1 related to the factor pairs you just listed? They are the rows and columns of the array. And see what mathematical operations can you use to determine the factor pairs. Once again, multiplication and division. And D, how will these operations help you determine the factor pairs? Erase all this. I multiply the numbers together, I divide them out, make sure they equals 18. That's it. That's your first video. You are done.